Okay, so here's a program that I wrote to generate a truth table. So I was thinking, well, it'd be nice if I could enter logical expressions and have the Teensy generate a result for me. It's a computer, so it can do that. And then I was thinking, well, if I hook up a bunch of switches to it, I can turn on and off switches. And I realized that was a lot of extra wiring, and I would have to press a lot of buttons at the same time, and it seemed like it was going in the wrong direction. So what I did was, I thought, well, why don't I write a program that counts from 0 up to some number and generates the equivalent binary values, and then I can run the truth table. So let me walk through this program and explain how it evolved. All of these programs start out as very, very basic, just trying to get it to function. And when it functions, then I can start to add additional features to it, maybe clean it up a little bit, make it look better. So let me walk you through it and explain how that evolved. Okay, so these are all comments here at the top. Basically, it's set up to process 4 inputs, what looks like 4 inputs, A, B, C, and D, 16 combinations, 2 to the nth power, where n is the number of inputs. So 2 to the 4th is 16. Okay, I set it up to process 2 outputs, output X and Y. If you want to add additional outputs, you can easily do that at the bottom, and I'll show you how to do that. However, if you decide to run like 5 inputs or 6 inputs or 100 inputs, it runs off the terminal display next door, so it gets to be a big problem. So 16 is a good number. It fits on the screen, and it does what it's supposed to do. Okay, so if you want more inputs for a challenge, what you might do is modify the print function so that it only produces active outputs. So let's say, for example, I had 5 inputs and 32 combinations, and an output X was only on when all the inputs are on. Well, there's no sense printing out all those zeros off conditions, so that would shorten the printout dramatically. So think about how to do that. So here's how it starts. I open the serial monitor, 115.2 kilobaud. Pin mode 6. 6 is my push button. Okay. Here's the loop. I create a variable called X. X is an indicator to tell the program if you should run the print routine or not. Okay, and you know, in hindsight now, I'm thinking about it, I probably don't even need that, but it serves a purpose. I'll show you here in a second. Pin number 6, not visual read 6. The reason the exclamation point is there is because I pulled up pin 6, so it's already high, and what I'm doing with the push button is grounding that pin. So when I ground it, it goes low, and that's the active condition. So I invert that right here. Pin 6 is the value of the push button, inverted. So that invert clears up that backwards logic, the inversion, and you don't have to worry about it after that. I also threw in a variable called count press, so you would know how many times you had pushed the button. So let's go ahead and run it so you can see what I'm talking about. Okay, so over here on the left side, D has a value of 8. I'm going to scroll down just a little bit here. C has a value of 4, B is 2, A is 1. So here's 0, and X and Y are zeros. Okay, off. A is on, off, 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 off. Down here, if A, B, and C are true, then X is true. And it looks like it's also true if D is true. Okay, so it looks like it's A and B and C, or D. And we'll see in just a second that is the expression. How about Y? Y is on if all 4 inputs are on. So that's A and B and C and D. So let's look at the program itself. So what I do is I check the status of the input, pin 6. If I haven't executed the print routine and the pin is true, that means I pressed it. Let me press it again so you can see. I just pressed it. What I do is I print this long series of dashes here at the top. Okay. I print the, I update the count press because initially it's 0. Okay, and so 0, you know, 0 is a valid number, but when I push it, I want to see a 1. So I increment the count press. I print a little text here, press number. There it is, press number space count press. So I'm just framing it so that I can read it as a person. A human can read it. Then I execute the function called counter, and that does the rest of it here. Then I print another series of dashes to close it off at the bottom and a blank line, and that's it. Then I make X true, which means that I just executed the print. I wait a tenth of a second just to give it time for the push button to stabilize, right? And then I start to look again. Well, now X is true, so this won't run again. Okay, but if I let go of the push button, it's true, it's false. I reset the X value, and now the next time I press it, I can run it again. So it's a way of controlling, you know, both the press. Like, let me do it again. There's the press and the release. So you don't see anything happen on release. I could have it print something. Let's do that. So let's have it print. How about a little message? PB has been released. Okay, so let's upload that. Now I should get a message. It's always good to get messages. You know, you want to help people understand what your program is doing. So there's the press and there's the release, and the press and the release. So I think I would like to get rid of that blank line at the bottom, and I'm going to actually add it here just to format it a little bit. Let's try that. So once again, I get the program to work, and then I tweak it and then modify it and make it look better, produce a better output. Okay, so maybe I'd like to have a couple of extra lines. All I would have to do is just copy this, maybe one more line. You know, I don't want to go overboard, you know, mess up the formatting of the whole thing. So let's just try a couple of blank lines there. Okay, press, release, press, release. So the reason I have it print the number is so I can see as everything's scrolling around, I can see, okay, there's the data for number 4, there's the data for number 5, etc., etc. Notice how it's not really changing. It is because down here in the counter routine, let me walk you through this as well. I've got 4 bit values, A, B, C, D. I have 2 outputs, X and Y. This prints the header right here. Then it sets up a counter 0 to 15. That's the 16 combination. 0 is a valid number. Here's something interesting. A equals I, which is the count, and 1. So this is the single ampersand. This is a bitwise comparison. This is not the double ampersand, which is a logical comparison. So I'm checking to see if there's a 1 in the count I. And there's 1 right there because it's count 0, count 1. Count 2 has number 2. Count 3 has a 2 and a 1, so it's counting in binary. It's kind of a neat trick here. I thought for a while to figure out how would I make it do this, and this is how it worked out. here's my logical expressions. X equals A and, this is the double ampersand, so this is a logical and, A and B and C, or D. So let me get rid of the or D there. What that's doing for me is turning all these ones on right here. So let's upload that, and I'll run it again. And now you see that all those ones went away, except this last one here. So maybe, you know, the reason it turned on here is because A and B and C didn't consider the D right here. So what I'm going to do, just to be 100% sure, I'm going to say and not D. Okay, so I don't want the D to have any effect on it. Let me think about that before I upload it. It's going to zero this out. It's going to make that a 1. It'll be okay. Yeah, let's upload that just to double check. That's why I made the program. It's a truth tester. So let's see what it does. And sure enough, so it's inverting the D value here. So it's a 1, and all these ones gives me a 1. And then here it's a 0 because it's inverted. So it's you know, considers all 4 inputs now. The Y value is just A, B, C, and D. So let's say I would like it to be a 1 up here. I'm going to invert all of these variables, A, B, C, and D. And let's upload that. So it's a good little tool to validate the logical expressions that Logisim produces. Well, let's run it, and you can see my 1 moved up here now. So it's a quick way to run all the combinations. If I wanted to throw an extra input in there, like E, what I would do is I'm going to comment this because I don't really want to do it. E is equal to I and 16. Okay, now, well, I could leave that in there. I could actually make it a new variable. I would just have to declare it up here. Like that. And I would have to add another serial print right here. What it'll do is it's going to run off the screen. So I might as well show you what that looks like. I did it earlier and I thought, well, that's a mess. So I kind of backed off of that. It sounds neat, but then again, it's a mess. So let's just run it and see what it does, and you'll see what I mean. Well, it would help if I change the count to 31. 0 to 31, that's 32. 2 to the 5th power is 32. So let's run it. And there it is. It's really, well, it's just barely off the screen. But, well, I left out something here. Let's put the letter E in there, and let's run it again. There we go. So now I've got A, B, C, D, E. E is, you know, what would really be handy would be another column to the left here that shows the value of I. So let's put an I there, I space space, and let's have it print the value of I, just so I can keep track of where I'm at. This is the formatting part where it's just nice to kind of clean it up. So I'm going to put the value of I think that'll work. Let's upload that. Zero, 1, 2, 3, 4, 5, 6, 7. So here's 16. That's oh, I messed up my formatting really bad. That's too bad. Everything was nice when I had single digits, but when I hit 2 digits, I messed it up. So, I mean, I suppose I could change that, I would just need an extra space in front of it. So let's see if I can do that program-wise. Right here, I'm going to say if I greater than 9, so if I'm at 10, what I'm going to do is print this. I'm going to print with one less space. If it's greater than 9, no, I'm gonna leave 2 spaces in there, and I'm gonna copy that, and I'm gonna do this. I'm gonna say that if I is greater than let's see, I'm going to do a less than. If it's less than 10, I want to have an extra space in there. Okay, so let's upload that. And let's run it. And it didn't work right. No, my mistake. What I'm trying to do is push things over. What I need to do is push the header over by 1 just to make everything line up right. And then I want to add a space, but I'm printing the value of E before I print my spaces. So really, I'm going to get rid of all of this right here. So here's the troubleshooting part of it, the debugging part. If I had thought it through a little bit more up front, I wouldn't have this problem, but I'm gonna have it work here instead. So this is the problem with doing things on the fly. It's okay. I'll get through it. So I'm gonna have E print out normal no matter what, but I is gonna be adjustable. So it's gonna print if it's less than 10. I want it to print with an extra space in here to buffer, to pad that over a little bit. And I'm just going to copy that and paste it. I realize there's another way to do that, but if it's greater than 9, I'm going to do it like that. Okay, so let's give that a try. Well, got that part right. If it's greater than 9, I want to take out the space one more time. And I need to do one more thing to it, but I'll get to it. Looks a little bit better. Okay, a lot of work, right? But this is part of learning about the details of programming. There's always something else you can learn here. That looks okay. I would just leave it like that. One thing would be neat is if I pushed over the value of I, if I pad it by 1, and that would happen here. That would be easy to do that. What I'll do is copy this. When I say easy, nothing's really easy, but I'm going to pad it, and I'm going to put one space right there. That should push it over by 1, just to line up the digits to the right formatted, I guess you'd say, like so. And of course I messed up. Let me take out this, take out a space. But if I add a space, I would take out a space, and I'm going to pad this over by 1 right here just to make it line up. Okay, one more time. Yeah, I think I can probably stop. Well, the E's over too far. No problem. Fix that. One more time. There we go. I like it. I can stop right there. If I keep going, I'll just mess it up again. So here's the value of I. This is the count. Here's the value of the 5 inputs, 0 through 31. Okay. Here's the X and Y values. Notice the Y, none of them are considering the E value. So let's just make up a let's change. I don't know. Let's throw a Z in there, and Z will be all of everything's on. Okay. So I'm going to copy this right here. I'm going to paste it. Make that a Z. I'm going to put an expression for Z right here. So the point of this exercise is, it's getting kind of deep, but they all do. The point of the exercise is to interface a push button, right? A 3.3 volt interface, really just a ground, and generate truth table results, so we can better understand how that works. And I'm gonna put this as a B, C, D, and E. So I'm gonna do it and E right there. And I lost a letter. Okay, let's upload that. And I'm about to stop here. It's running kind of long, so let's watch it run. There's my, where's my Z? I guess I never printed that. Okay, so let's do X, Y. I need to format it a little bit, so let's pad it with a couple of spaces, and then let's copy and paste. Right here, we're going to do the Z right there, X, Y, Z. And I don't want this, I want the print line. This needs to be a print, not a print line. So X, Y, and Z. Okay. Okay. Last time here. X, Y, Z. I've got. I don't see a. Let's see, what did I do wrong here? Well, it would help if I changed it to a Z here. Okay. Details. One more time. I think that's my new favorite saying, one more time. There's no point in getting frustrated. It's doing what I'm telling it, but I'm not telling it the right thing to do. And there's my Z right there. Okay. So that was press number 1. Let's hit it again. Press number 2. Same results. It won't change, of course, until I change the program over here, which means it dumps everything out. So there we have it. I'll stop at that point because it got longer and longer and longer. And what I'm going to do is copy the. I guess I'll copy this code to Blackboard so you can download it and upload it, which is fine. I don't want to make it harder than it has to be to get started. So what I would ask you to do in class is to look at a way to modify the printout here. So like all these zeros where there's no active result. You know, if X, Y, and Z are zeros, don't bother printing that out. Okay, just skip that over. So you'll print out this first row, you'll print out this row, anything with a 1 you'll print. So that'll give you something to think about over here logically. Instead of just spitting out all the values, you'll just produce a few of active outputs. Okay, so I'll stop there.